All right, here's the video for note 6-4, binomial probability. So just as a reminder, binomial notation, N describes the number of trials or observations in the binomial experiment, P represents the probability of success on an individual trial, and K represents the number of successes you are interested in. But what if you're interested in multiple successes? So looking at this example, it says Billy Bob takes a true or false test of 6 questions and has absolutely no idea how to answer any of them, so he guesses on all of them. If 4 questions correct is passing, what's the probability that he passes the exam? All right, so in this case, we know that he passes if he gets a 4 out of 6. We know he passes if he gets a 5 out of 6. And we know he passes if he gets a 6 out of 6. So in this case, we're really looking at 3 different possibilities of him passing, but we can also write that as an inequality that x is greater than or equal to 4. In this problem, he's taking a 6-question test, so n would be 6. The probability that he guesses right, it's a true or false test, which means the probability is equal to 0.5. And in this case, k is whatever it is when you write it, so this is going to be k. K in this case is going to be 4. So we're going to put that in our binomial calculator. All right, so probability of success we know is going to be 0.5. Number of trials is how many questions on the test is 6, and we know that k is equal to 4. But in this case, since we are looking at a cumulative probability, we want x is greater than or equal to 4, so it's going to be in this case, so that's going to be 0.3438. 0.3438. So it's going to be 0.3438. So the probability that he passes the exam is 0.3438. All right, so cumulative binomial probability refers to the probability that the binomial random variable falls within a specified range. So instead of looking at one specific outcome, we're looking at cumulative, meaning multiple different outcomes. So in this case, if we say x is less than 3, we're looking for x equals 0 plus x equals 1 plus x equals 2. So in our binomial calculator, we're going to be looking at these bottom ones. This is when we're interested in multiple successes. So a variable falls within a specified range. This is if we just are looking at one particular, like x equals 3. This is if we want a specified range. All right, so let's look at a couple examples. It says in a particular city, 63% of adults own their home, 37% rent. A sample of 20 adults is taken. Find the probability that the sample will have at most 10 homeowners. So first we need to write that in terms of x. At most 10. At most is a less than or equal to symbol. So we're trying to find the probability that x is less than or equal to 10. N in this case is our sample size, which is 20. P is the probability of success. Since we're looking at homeowners, we're going to use 0.63 for P. And in this case, again, K is whatever it is when you write it in terms of x. So K is going to be 10. So using our binomial calculator, so probability of success is going to be 0.63. Number of trials, that's our sample size. And we want at most 10, so that's going to be 10. And since we're looking for at most, that is less than or equal to, so that's going to be 0.1650. So 0.1650. So in terms of the context of the problem, I'm just going to say this verbally. The probability that a sample of 20 will have at most 10 homeowners is 0.1650. All right, looking at example 2, it says in a particular city, 63% of all adults, the same situation. We have the same N and P, but we're going to write it in terms of X. More than 12 is greater than 12. So N is still 20. P, we're still looking at homeowner, so that's going to be 0.63. And K is whatever it is when you write it in terms of X. So that's going to be 12. So using our binomial calculator, again, we have 0.63. Number of trials is our sample size, and we're looking at more than 12. So entering in our numbers, more than 12 is greater than, so it's going to be 0.5265. So the probability that the sample will have more than 12 homeowners is 0.5265. All right, so here's some more examples. So first writing in terms of x, exactly 3. Exactly is an equal sign. N in this case is 15. P in this case is 20%, so 0.20. And K in this case is going to be 3. So N is 0.20. Number of trials. Oops, now I can't remember. Number of trials is 15. And number of successes, we're looking for exactly 3. So exactly 3, we're going to look at this first one here. It's going to be 0.2501. So the probability that exactly 3 of the 15 sampled have no health insurance is 0.2501. So in this case, at most 1 is less than or equal to 1. And we still have the same N is 15. We still have the same P is 0.20. And K we're going to use as 1. So let me shrink this down a little. Might be a little easier to see if I can shrink it. There we go. Point 2, number of trials, we're looking at 15. Oops. And number of successes, it says at most 1. So since we wrote it as less than or equal to 1, we need to look at the right one. So it's going to be 0.1671. So the probability that at most one of these has no health insurance is 0.1671. More than 7, same N, same P, and K, we're going to use 7. So 0.2, 15, and more than 7. And more than is the greater than, so it's going to be 0.0042. So the probability that more than 7 have no health insurance is 0.0042. At least 1, at least is greater than or equal to. So 0.2, 15, and we're looking for at least 1. So greater than or equal to 1, that's going to be this last one, so that's going to be 0.9648. So the probability that at least 1 in your sample has no health insurance is 0.9648. All right, looking at a couple more examples here. It says, what is the probability of obtaining at most 45 heads and 100 tosses of a coin? So at most is less than or equal to. And in this case, we're tossing the coin 100 times. P is the probability of success. We're counting the number of heads. The probability of getting heads is 0.5. K, we're going to use 45. So we have 0.5, tossing a coin 100 times, and we want at least, or at most, 45. So at most less than or equal to, that's going to be 0.1841. So the probability of obtaining at most 45 heads and 100 tosses of a coin is 0.1841. Second one, student accepted to prestigious college is 0.3. If 5 students from the school apply, what's the probability that at least 2 are accepted? At least 2 is greater than or equal to. N is 5, since that's our sample size. P is 0.3. And K, in this case, we're going to use 2. So the probability of getting into the school is 0.3. Number of trials, we're looking at 5 people, and we want at least 2. So at least is greater than or equal to, it's going to be 0.4718. 0.4718. So the probability that at least 2 are accepted is 0.4718. All right, lastly, if you feel like you need more practice with these, you can go ahead and do these ones. The answers are on the next slide. So these are the answers, making sure that you're plugging in things correctly and looking at the right area on the table.